challenges here. There's going to be the ego car is coming from the bottom and coming up to this intersection here, and then traffic is going to start crossing in front of us, and it's going to temporarily start occluding some of the cars ahead. And then we're going to be stuck at this intersection for a while and just waiting our turn. This is something that happens all the time and is a cartoon representation of some of the challenges here. So number one, with respect to the feature queue and when we want to push into a queue, obviously we'd like to have some kind of a time-based queue where, for example, we enter the features into the queue, say, every 27 milliseconds. And so if a car gets temporarily occluded, then the neural network now has the power to look and reference the memory in time and learn the association that, hey, even though this thing looks occluded right now, there's a record of it in my previous features, and I can use this to still make a detection. So that's kind of like the more obvious one, but the one that we also discovered is necessary in our case is, for example, suppose you're trying to make predictions about the road surface and the road geometry ahead, and you're trying to predict that I'm in a turning lane and the lane next to us is going straight. Then it's really necessary to know about the line markings and the signs, and sometimes they occur a long time ago. And so if you only have a time-based queue, you may forget the features while you're waiting at your red light. So in addition to a time-based queue, we also have a space-based queue. So we push every time the car travels a certain fixed distance. So some of these details actually can matter quite a bit. And so in this case, we have a time-based queue and a space-based queue to cache our features, and that continues into the video module. Now, for the video module, we looked at a number of possibilities of how to fuse